explanation and stuff. But anyway, you can see how these parts are assembled here. This is almost a what would they call this? Tongue and groove or something like that. I guess they call these particular assemblies here. The way I did this is just to make these two parts separate, because if you do this on a 3D printed part, let me see, where was I? So if you do this part on a 3D print part, it's a single piece. You basically, this becomes like an L shape. And the way this prints, one way it's going to be more stronger than the other. And so it's better to just separate something like that L bracket. And it's two pieces as you see them here. You can see the assembly, well, this was the original assembly as a complete L bracket single piece, which you can also do as a single piece, but it's much better to do it this way. You can see here, like I was saying, the single piece right there that I originally had, and then from this I went to this right here, as you see it underneath the table right there, because it's much better to have those two pieces separate and have them interlock in the assembly, to create that L bracket here. And this I use a little bit of CA glue here when I assemble these parts, and they become a lot stronger because they're printed flat. So the bias, the layering of the filament is done horizontal, so it becomes a much stronger part because it's layers, almost like the way plywood is built, in layers with epoxies, with glue. The more layers, the stronger the tensile strength of the part becomes. So that's the way these parts are designed, with that mentality in mind. Anybody that designs for 3D printing will probably understand this, if you're a seasoned designer. So that's basically that's the part that I'm going to, like I said, I'm going to modify for these very simple solenoids, which I'm still going to have these little simple solenoids because they work really well. But these are more like the real things. These are a little much better, but they're more complex. You can see there's a lot more parts, a lot more work that needs to happen here. These right here, as I was saying, let me just complete the design here. I was saying that these carbon rods, there's another gentleman that I mentioned that has a similar setup. He's using a threaded rods here to do what I'm showing here with a simple carbon rod in some pressure fitted vinyl PVC tubing. So basically, I have that set up right. So basically, I have this setup right here, and there's one. So there's one on top. And there's another one at the bottom here. Okay. And because this is actually set up with this top being at the maximum height here, this is not going to go any further in the up direction, but instead it's going to come down and return to that location where that you see it there, because the solenoid only triggers downward from that position that you see it there. Triggers downward, brings down this whole assembly here with the top hat, and that's what triggers the ball. Once this plate right here originates that trigger point via the way I explained, via that screw and brass tubing that's embedded into this layout right here. I should actually bring this over here to complete that, or over here to complete that assembly. But I think you get the gist of this. The point, the bracket here, once again, it's a two-part bracket. The way I'm showing this, well, this is the original single piece bracket, but like I was saying, with the brackets, with the layout for 3D printing, I just broke that bracket down to two pieces. Let's see, here's the original bracket. It's one piece. you know, but for 3D printing, it's a lot better to do it this way right here, as this bracket right here and this bracket right here. You can see that these two pieces are interlocking, and the result of these two pieces interlocking, the original bracket, the two pieces interlocking, and this is the way it would be assembled right here. If you can take that part, it just slides right on top of that other part right there, with once again a sort of a tongue and groove. You know, you can see these things are angled, you know, to interlock these two pieces together once you put a little bit of Sea glue. So let me undo that last step. So basically that's how those parts are done, and they are much better mechanically from a 3D printed form. You know, once they're printed flat like this. Well, this part is printed flat right here. This is actually the assembly for the group of parts that I print for those particular electromagnetic solenoid triggers bumpers. So these are my parts there, and I print those in white, and I print these in blue. That's why you see these parts in blue here, translucent blue. The other triggers that I'm using here are for just regular type switches, and these are the parts for those triggers are right here with the bracket and the arm for those switches, the contact switches that you can buy commercially. Let me show you what that switch looks like. I believe I have one underneath here somewhere. Where is that switch? I typically organize all these parts once I'm done with all this crazy layout here. I just like to spread, you know, as I'm doing this, I don't particularly keep any an organized mentality. I mean, there's organization in my head. I know what I'm doing. I know where things are at, and so there's organization there. But as far as the layout here, I just spread out, and then once I'm satisfied with the parts, I start organizing them in groups. Like I said here, there's a group of parts right here. There's a group of parts. There's another group of parts for the blue pieces of a group of parts there. These parts is a group. That part is a set of a group because those form the switches that I'm trying to find here. Here's another part. You know, it's a group of parts for the flippers and so on and so forth. You know, it's just common sense. Here's the other parts for the this is a recent setup here for the slingshot. I'll explain the slingshot in more detail in a little while here, but let me try to find the switching here for the, what did I do with the switches here for the let me cancel that. Where are the right here. There it is. They're hiding. Okay, so these are the other brackets for these switches, and you can see these are the typical contact switches that you can buy, you know, online or from your local electronic store. You know, they typically are, you know, they have three tabs with this little contact point here, and then they have an arm. What I did, these are the ones with the rollers. They come with a little red injection molded plastic roller. So I removed the roller so that I can install these extender arms here. And this would be a trigger here for a. I was actually using these for my flipper bumpers or the bumpers that are near the flippers. So these switches right here, the way they are laid out here, there's one that's laid out vertically, and so this is that was one of the switches before I started contemplating the slingshot full assembly. Here's another switch that's more horizontal, that is triggered by, you can see that little ball sticking out. So if I were to press this right here, if the ball were to come over this this part that's sticking up, that's part of this long arm that's connected to that contact switch. It would trigger the switch. So it's a couple of ways to trigger things with these switches, with these extender 3D printer arms. And so the brackets are also designed to hold the switches in the way that you see them there. Now these brackets, because they're very simple brackets, very, very small brackets, these are, I believe, I made them beefy. This is a 1/8 of an inch thick, this part right here that attaches underneath the table, and these are a little bit thicker parts here, just to keep the bracket nice and beefy. You don't want a wimpy part there, especially if you're constantly hitting this switch on and off, on and off. So that's the idea behind this these types of switches that you can use with readily available switches here. And let me show you where this switch right here, the way I have it right now on my machine. This right here is already on my machine at this location here. At these points, at this point right here, there's a hole there, and where that switch is coming up, and there's another hole here for these bumpers right here, for these type bumpers. And like I said, I did that before contemplating doing what is called a slingshot return, or slingshot solenoid assembly. And so that's what you're looking here, is the updated version with the slingshot operated by a solenoid here. So you can see that I tend to do this little sections of the table with the parts as I'm working, independent of the actual machine here. I could do it there, but it gets a little too cluttered, when you start working. So it's a lot easier just to grab a section of the table and start building your individual components or assemblies this way. At least in my view, this is how I work. I like working, and it works for me. There's so many ways to do this, and it just depends on the individual designer, how she likes doing things. So basically, this is the reason I did this last night. As you can see, the assembly here more in line with the this, what you're looking here, it would be the rubber ring that goes around these parts right here. And I did not draw the whole complete ring or band because it's not required, for this study here. As I was studying this, I was building these parts, but just enough to give me the layout and the location so that I can position these leaf switches, and also this kicker arm here. And you can see this was my first layout here, just to study it, and this is the complete assembly right here with the function of that slingshot kicker assembly. You can see the original, the kicker part is, or the slingshot part is steady right here, right behind this band right here. The switches are right behind the band, so when the ball hits this band here, it triggers depending where the ball hits. If it hits on this upper portion of this band, it's probably going to trigger this switch more than this other one here. But if it's on the lower part, it's going to trigger that other one. So these two switches allow for that. Switching with more precision than if you just would have one. And then this is the kicker that gets activated by these switches here. So when the ball makes contact here on the inward part, it gets returned. That's a slingshot function. It gets returned, it gets kicked out, by pushing this band, boom, and with the ball with it out of the way. So it's a very effective setup there. And once again, this is I came up with these things. This is my own kicker with my own parts, my own layout, just based on studying the mechanics of these slingshot solenoid assemblies on the full scale ones. There's a number of ways that you can make the brackets here, the layout here. I could have joined. In fact, I could join these brackets here. This bracket here, I could join to these other two brackets that are supporting these leaf do-it-yourself contact switches here, just to make this whole thing a one-piece assembly that installs as a one setup, or one part. and that way you don't have to individually attach these and mess with aligning them and stuff like that. These require 3 holes, obviously. The one hole for these leaf switch assemblies, and then a larger one to allow this kicker, to clear as this is being actuated by this solenoid here. So you can see this drawing right here is actually, this is the steady the idle position, and this is the action where as this pulls down. This pulls down about 0.4 inches or 10 millimeters is the length of the pull here on these typical solenoids. You can see the numbers there, the voltage there. I use 24 volts because it's more efficient, if you use a higher voltage, lower current. And these are 5 Newton solenoids, which is perfect for this machine. This machine is not a full-scale machine, a full-size basic rather, but it's almost like a half scale or 2/3 scale size, with the dimensions of 16 by 30. That's the dimension of this machine. That's plenty for immersive fun, with all these LEDs that I'll have added to this machine once everything's done. You have to work on these things one at a time and make sure that everything works fluid before you move on to the other one. Here's my actual setup, mechanical setup here. For the kicker, mechanical kicker, and here's my setup for the flippers that run on these ball bearings. So my flippers, as I was saying, they run on this ball bearing here. You can see the ball bearing right underneath. Right there's the ball bearing. Here's the little cup, that supports the ball bearing, and that goes on top of the table. And so it runs more precise, and you can kick forever with these things, and it'll be pretty solid. There they are, the full assemblies right there. The rest of the machine basically is just geometries, pieces that allow it to establish this pattern here of curvatures. These right here, I'm still playing with the layouts here. I've done a few test setups, test parts. Here's an idea that I had, with the ball traveling via these parts. I created these parts right here. So a bunch of these parts, you can join a bunch of these parts with just some nylon tubing or nylon rods, flexible rods, and you can create this track here for the ball. You can also use metal rods or metal brass tubing, to create this track. This is right now, it's a straight track, but you can curve this, and all these parts allow you to do that because it maintains a parallel distance between whatever you put here, as far as these track rods. So I did this setup, in as an option to creating these vias here, or these pathways to create tracks and bridges and stuff like that, returns to the ball. This right here is just a single piece ramp that I did, but I didn't quite like the way this came out. I did this. There's an easier way to do this than a 3D print part. This took a little while. The other thing to consider is that, or at least that I like to consider, is the timing that it takes to print all these parts. Some of these parts, because of the thickness and the way the infills need to be, on some of them need to be a little more stronger. So you obviously put more infill than some other parts that don't require as much strength. These can be also thinned out from the thickness that I use. I use 1/4 inch here, so this is a 1/4 inch. Yeah, it's about 1/4 inch in thickness, and so these can be 1/8 even. These track walls and guides. but that's the way it came out, and so that's the way it's done. Like I was saying, this is my first prototype, and I'm pretty sure that I will refine this if I go the extra distance. It's a project that I'm not in a hurry to do this. I'm taking my time. I'm doing this in my spare time, and just to break the routine of the other work that I do with the radio control microlights, RC ultralights, and all the auto gyros, etc. All the stuff that's on my website. That's been there for sale. I'm a little bit slow in terms of kits for customers, so that's why I'm doing these projects right here, and I'm okay with that. I mean, I'm not complaining, and I'm not trying to advertise for my other products. I mean, I really like having the time to do this and getting my mind involved in some other things other than the stuff that I've been doing for the past, I don't know, 50 years. So this is kind of fun. And this is the reason why I'm sharing also all this information and all this work here with viewers. That if you find this interesting, give me a thumbs up. If you have any comments, questions, put them down below. And it's typical my videos. They don't get a lot of views for some reason, as I explained. I have a suspicion, as I always have had, that it has to do with an algorithm, or just maybe some things that I may have said before, or shown, or maybe it's just somebody has triggered a little algorithm, to not let my stuff appear as often as I think it should appear, because I see a lot of crappy videos, and those get a lot of views, and stuff that when where you're showing people how to do things in detail, that doesn't show as much. You tend to question those things. So, but like I said, I'm not going to. Not going to engage in any complaints or discussions about that, but it's good to mention that, so that it doesn't remain silent and hidden. That out of the way, let me continue with some of these other things that I've been working on. Basically, as you can see, okay, so let me go back to this part right here, because this is the latest part, the latest assembly that I mentioned. I've been working on. I explained in my other video that these switches are basically 3D printed parts. This T right here is a 3D printed part, and the way I came up with this is, you can see some of my sketches here. Let's see. This is the actual circuit for the solenoid. I show this in another video, so I'm not going to show that there. Yeah, this is sort of my sketch. Do-it-yourself contact leaf switch, and okay. So basically, I'm showing basically a clean version of what I just showed you here in my sketch. These are just to reiterate this, and just go back and make this a complete video here. These are beryllium copper, BERYLLIUM, I believe, is how it's spelled. And this is this material right here. And the reason why I'm using this particular type of copper is because it has a spring action to the spring properties to the material. If you were to use just regular copper, if you were to do what I'm doing here, it would bend real easy. So it does. This has a little bit of a memory, so it comes back to its original position, provided you don't go beyond a certain point, because then you'll crease and bend the material. But it does have that spring quality, which is great for what we're doing here, because you have the band that wraps around the bumper, and when that band gets hit by the ball, it's going to do this, and it's going to make contact with the background right here, and so that creates the switching here. This right here that you see here, this V, is just to I could leave it without this V right here. It's not necessary, because this is going to make contact regardless, either way, flat or with this angular V here. But this is more in so that it engages with almost like like a cup, you know, to this part right here, to the band. So that's what that V is more for. But basically, you know, they're just these two leaf switches, and this needs to have some kind of an insulator between them so they don't short out. You know, in when they're normally open. This is a normally open circuit setup here. And so this 3D printed part is acting as my insulator here. And it's got two perforations, both on the 3D printed part as well as on this. Let's see if no. This part right here needs to be modified. Let me remove those. There we go. Okay, so basically these are through holes that go through that 3D printed part, the insulator, and this is going to be attached with nylon, some small nylon screws and nuts, so to retain that part right there. The more commercial ones are done with fiberglass sheets as the insulator separator of these contact switches, and they're joined with some kind of a also an insulated sleeve or a retainer here between these two points here. So that's how the more commercial ones are done. You will be paying anywhere from $5 on up for each one of these things if you go online and search for these things. So I wasn't willing to do that. I had the material, and so I decided to make my own. And this is basically how you do that. It's very simple. If you don't have a 3D printer, you could make these, like I said, with fiberglass. You can make these with plastic pieces. I mean, even wood, you know, as a separators and insulator. Basically, you're trying to separate these basically by a certain distance, enough to create a gap here. So, but also to create enough length here to create a flex here. You know, just a very easy flex. So when the ball hits, you know, it hits the back one and it creates a contact. This at the bottom right here is just this extra geometry is just to simulate a contact point of a solder point for the leads that need to come out here and connect to the rest of the circuitry. That is part of the solenoid trigger mechanism. These parts, I did them individually, as you see them here. These T's here, the supports for these leaf switches, as well as this assembly here. And this assembly is very similar to my other one that's over here, to that one here, and even this one over here. So very similar to that setup, except that I modified that part, the support for the solenoid, because it also has to support this pivot point here for this arm here. This is where this is pivoting, so that this slingshot kicker gets activated via this solenoid here. So that's how this is set up right here. And the parts for that is what you're seeing here is one group of parts that are laid out again, so that when you print these, it prints flat. And once again, this part gets assembled at 90 degrees. This part right here that you see here gets assembled at 90 degrees with this part right here via this this tongue and groove geometry here. Once this is assembled with a little bit of CN glue, this has a tolerance, a very not too tight of a tolerance, but not loose again. But it's got I think a 3 thousandths of an inch in spacing between these parts here, and this just to allow this part to assemble easy here with a little bit of CN glue. So that's the way I'm doing these parts. This arm right here, I actually broke it down into two pieces here, and the reason why I broke this down into two pieces is because this part that you see in here, here's the top portion of that piece. So if I were to lay this, let me do that, so you see what I'm actually talking about. So if I were to grab that part, I don't want to change the location of that because this is already set up for printing. If I were to put that part on top, you'll see the full assembly here in just a little bit here. Go 90 degrees, and this part right here, if this was a single piece, would look like this. Would look like this as a single piece. Now, when you print this right here, you're going to have a gap here. Now you can do this with supports, and it'll put supports underneath this slot here as you're printing this part flat horizontally on the 3D printer table. But I didn't want to have this gap. I didn't want to have supports here, and so what I did is I broke this design here, this whole piece, into two pieces, and that's what you're seeing here. As let me just get rid of that. And that's what you're seeing here is two pieces right here. So when this gets assembled, because this has a pivot point here, and this has also the rest of that pivot point, this is going to align just fine. And also this gets attached to this part right here, you know, to the solenoid shaft. This has to be bolted down anyway, you know. So these two pieces, that piece. Let me show you this. I'm talking without the full picture here. So this part right here gets assembled to that, as I was saying, and because this is the pivot point, and this is the top portion of this part right here, so that pivot point gets attached, you know, with a bolt through to the other arm. Well, not through the other arm, but to this point right here, because this is the pivot point, the bracket. And because this part right here, this section right here, and this section right here gets attached to this part right here, that gets attached to the solenoid shaft through another screw and nut. These two pieces right here become one. So imagine this part just being one piece right here, but for printing purposes, I separated them the way you see them there, and it's a lot better when you do things that way. Actually, this part I need to bring down, because it's a little bit higher than what it should be for the layout of the 3D printer. So I'm going to bring this down to the same level here, and there we go. So everything's on the same plane. Okay, so now I can just slice this assembly here and do my parts from there. So this is where I'm at in my next video. I'm sorry that this has gone for so long here, but you know, if you've been keeping up with this, thank you. Please do comment. If you have any comments, if you have any questions, like I was saying, put them down below this video. But in my next video, I will show the actual mechanics of this, a complete assembly. I'm about to print this part and finish this assembly, modify my table here so that I can install all these pieces on the table, and then I will show you what that looks like. This right here is, you can see this section right here is where the ball travels. I should just maybe comment on this as a final detail. This track right here where the ball travels is, you can see these strips right here are a bunch of LEDs here, which I'm representing them with these tubular blocks here, or tubular sections. And this right here actually has a clear lens, which a section of clear lenses, which are, I did them like this only because my machine can only print in lengths of up to 10 inches, diagonally maybe a little more, but I kept them